right? So given the equations, we're going to graph the line. So sometimes lines can be parallel. And before we even start, notice in this one, the slope is 3. And in this one, the slope is 3. All right? So they have equal slopes. So 5, that means I have a y-intercept of 5. That's where that goes. Now the slope's 3, so I go up 3 over 1. I'm off the graph. So I can also go down 3, left 1. That works too. All right? So something like this, we got this beautiful red line here, and then this purple line, a y-intercept of -2, then up 3 over 1. Oops. I'm struggling, keeps bouncing around. There we go. That's about as good as it's ever gonna get. But sometimes lines can be parallel or perpendicular. So this one, notice how the slope is -4/5. There is no y-intercept though. By that means it just crosses there at 0. So there is a y-intercept. I should say the y-intercept is 0. Down 4, to the right 5. Boom, and we got that pink line. And that one has a slope of 5 over 4. Again, no intercept. So up 5 to the right 4. And that's how we get that line there. And just think about like why this is important. I mean, I already told you that Pixar uses coordinate geometries. I mean, this is just one way we can make a right angle in a coordinate plane. Okay? Oh, this actually has a little typo in it. For neither, that should be a positive one. All right, so it's neither, it's a quick little typo. So we have a slope of 2, a slope of 1/2. Those are, oops, I wrote -1/2. I don't know why I keep doing that. Slope of half, that's neither equal or opposite reciprocals. Just because it's a reciprocal doesn't mean it's perpendicular. And I'm just doing this line right here in black, slope 2, so up 2 over 1, up 2 over 1. And I missed pretty bad. Let me try that again. And then -1 is, so yes, they still intersect. But notice how that's not a right angle, right? Not right angle, all right? So that's why it's like that. All right, so there's just an example of parallel lines, perpendicular lines, and just intersecting lines, all right? Just because they're not perpendicular doesn't mean they can't intersect. They still can. This is technically called oblique. They're intersecting at a slant. Nonetheless, all right? Given the equation, determine the slope which would be parallel or perpendicular to the line, all right? So in this case right here, the slope is 5, so the parallel slope is 5. The perpendicular slope would be -1 over 5. Because realize that in this case right here, it's a +5, and we can think it's over 1. But we typically don't write that stuff in yellow, all right? When there's not a positive sign, it's just implied that the numbers are positive, and technically every number is over 1, all right? In this next one, the slope is -2/3, so the parallel slope would be -2/3. The perpendicular slope would be +3 over 2. And again, I don't have to write positive, it's implied that it's positive. Q. Number C, the slope is -2, so the parallel slope is -2. And then the perpendicular slope, again, recall, this is like -2 over 1. So the perpendicular slope would be 1/2. Ooh, and look at this doozy over here. This one's scaring me. I'm a little bit terrified right now. We got a positive 41 over 52. So the parallel slope would be 41 over 52. The perpendicular slope would be -52 over 41. Nice. All right, so let's review the slope formula really quickly. The slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And the order doesn't matter. You could write y1 minus y2, but if you do that, so I even write it out, or it's y, consistency matters, all right? Order doesn't matter, but consistency. So either the y sub 2 and x sub 2 is first in both numerator and denominator, or y sub 1, x sub 1 is first in both numerator and denominator. So given the set of points, determine if the line that passes through them are parallel, perpendicular, or neither. So let's use the slope formula, because we do need to practice that. Of course we can count, we could plot the points, we could count, but we also have to be good at using a formula and all that fun stuff, because a formula never fails. Sometimes if the numbers are really far apart, you can't count. If there's decimals, it makes it really hard to count. So let's just say, well, what's the slope of line A? Let's calculate the slope, then we'll plot the points. Again, order doesn't matter, so I'm going to call that x1, y1, x2, y2. And I'm even going to write it right here. All right, so remember the slope formula. Now plug in everything correctly. We're going to get 5 minus 1 over 2 minus 7. So I'm going to get 4 over negative 5. So technically that's okay, but sometimes people just prefer to write it like that, negative 4/5. All right. Now the slope of, and let's go ahead and plot that really fast. All right. So 2/5, or 2/5 I should say, and then 7/1. Line's going to look something like that. Now with B, again, it can't hurt to label the points. And the slope of B, again, I'm going to write the formula out again. Why? Why not? And then I'm just going to plug in everything. 3 minus 7 over 1 minus negative 4. And remember, this minus negative 4 becomes a positive. So it's 3 minus 7 over 1 plus 4, which calculating 4/5. All right, so I don't have to graph this. We already know that the lines are going to be perpendicular based off their slopes. All right, we have negative 4/5. We have, hold on, time out. Brain fart. They're actually, so embarrassing that I almost did this. They are neither. All right, they are neither. I almost brain farted. All right, although they change signs. Actually, hold on. I'm brain farting again. Geez, I need fired. You guys need to throw your iPad and say this is stupid. All right, I'm so embarrassed. Negative 3 minus 7, that should be a negative 4/5. All right, so we've gone through all of them. They're in fact parallel. I'm sweating now. I'm so embarrassed. All right, this is the face I'm making. If you could see my face right now, this is what I look like. Just kind of shocked. All right, why are they parallel? Same slope. All right, anywho, we got 1, 3, and then negative 4, 7. This is the line right here. These two lines would never intersect. All right, I was just trying to trick you a couple of times, make sure you guys are paying attention. All right, hopefully that was a little entertaining to watch me fumble through silly sign errors. And that's what I say, a lot of these computations are easy. Finding the slope, not hard, but susceptible to silly mistakes. Make sure you avoid them. Even me, a math teacher, almost makes them every now and then. All right, so let's find the slope of Q. Let's just pretend like that last problem never happened, all the mistakes I made. All right, again, do you have to label your points every time? It's probably a good habit. But if you don't do it, just make sure you're really careful. So I'm going to get y minus negative 6, so y, or 2 minus negative 6, so 2 plus 6, and then negative 3 minus 4, which hopefully I'm not making any mistakes right now. I get 8 over negative 7. Let's go ahead and plot these points. So negative 3 would be left 3, positive 2 up 2, and then 4, negative 6. Okay. And then we got line T, and you get what I did right here, line Q, line T, QT, ha ha ha. I'm pretty funny. I'm probably the funniest math teacher you've ever heard teach math. Anywho, the slope of T is going to be 0 minus 8 over 2 minus negative 5. So 2 minus negative 5 becomes 2 plus 5. We're going to get negative 8 over 7. All right, and let's see what happens here. All right, so 2, 0, negative 5, 8. Okay, these again are parallel. And why did you notice how this was a slope of negative 8 over 7? So this is why he said sometimes you kind of just like to write the negative sign out front rather than just specifically with the numerator or denominator, whatever that might look like, but they're the same.